Hello, 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 and welcome everybody. We are still on for distance learning. Woo! So hang in there, and we'll see how long this whole thing lasts. We are now in marking period 4. So we're going to be going into electricity. Hopefully you guys will find this topic enjoyable. I think it's one of the cooler things we go into. And hopefully we'll get to do some more interactive things here as well. I'm sure you're a little bit tired of all the videos. So we'll try to do some more hands-on things virtually as best we can. Your first assignment is another video for the time being though. It is posted on MIME CPS under modules, distance learning marking period 4, electricity video notes. So you're going to watch a short video on how electricity is produced and different ways of doing so, and just answer a couple of questions. Should be really straightforward, get some free points, start the quarter off strong. It's due the Sunday, 26th, and if you have any questions, please email me. And I'm happy to set up a Zoom meeting if you'd like, or just answer you right there through email. I try to check my email every single day. I try to check it regularly throughout the day, so I try to get back to you really quickly. Please email me if you have questions. All right, let's talk about energy. So basically, all energy comes from the sun, and then in some form or fashion, we or other organisms repurpose that energy and use it for their own benefit. So you might say, well, wait a minute, Mr. M, oil doesn't come from the sun. Well, where does oil come from? Dead dinosaurs. And dead dinosaurs ate plants. And plants, of course, get their energy from the sun. So at the end, it all boils down to this beautiful star giving us all the energy we have. Now, we have different ways of producing it now, and some are more efficient than others, and some are renewable, and some aren't. We are using more and more energy today than any time previously in history, and as we go forward, it's likely our energy consumption will just increase farther and farther. So we have to keep thinking of new and interesting ways to develop energy more efficiently. Here is a chart of some statistics as to where energy comes from nowadays. This is from 2013, so it's a little outdated. This sector here has grown quite a bit since then, but these are still all very prominent. Natural gas is really large, as you can see. Oil is really large, as you can see. They have shrunk just a little bit, and this little yellow section here, the renewables, has grown, especially with more solar panels and more wind. But this is very close to what it is right now. So that's interesting to think about. Now, energy can be grouped into 6 major forms. I'll go over them really fast here. So you have mechanical, nuclear, electrical, chemical, thermal, and radiant energies. We're not going to do the TMAP activity, although if you would like to, you certainly may. Let's take a look at the kinds here. So mechanical energy is when you move something, right? So we associate this with machines. Wind and moving water are mechanical energy, which we often don't think about. If you pedal a bike, you're doing mechanical work. Mechanical energy is expanded. Radiant energy is any kind of energy that comes from a magnetic wave. So if you think about your cell phone, it requires a signal in order to function, or Wi-Fi, which we're all very much reliant on now. That's all radiant energy. But also light coming out from your light bulb, that's radiant energy as well. Chemical energy is when you break down a particular substance through some kind of chemical process and thereby release energy. When you eat food, your body processes it in this particular way. That's, in a way, how our bodies create their energies, through this chemical process. Thermal energy is anything that's hot, has thermal energy. Very straightforward. not much to say there. Electrical energy is where we'll be spending most of our time in this unit, so you guys are going to be learning quite a bit about this section here. All sorts of interesting things. We're going to talk about Ohm's law, we're going to make some circuits, we're going to talk about parallel versus series, and we're going to do some math. Maybe not your favorite, but it'll be cool. Most electrical energy is made through this process. If you take a large magnet and you take a coil of wire and spin it inside that magnet, the electrons inside the coil will start to get excited and they'll move. And as they move, you can do all sorts of cool things, like get a light bulb to turn on. Now, something to think about is if you turn on your light switch, how fast do you think those electrons have to move in order to get your light on? It turns on almost instantly. Now, lots of people would say, well, it's got to move at the speed of light. But that's actually not true. Electrons move rather slowly through a wire. Electrons move maybe an inch or two every second. So that's pretty slow. So how the heck does your light turn on so quickly? I'll tell you the answer at the end of the video. Let's keep going. Nuclear energy is associated with bonds in atoms. And when you break down those bonds, you can create really, really, really large bursts of energy. So we have fission and fusion, and different ways of taking advantage of those. So there you go. Those are your categories. Now we have also renewable and non-renewable kinds of energy. So if you burn up a piece of coal, it's not coming back. But you can put something in the water next to some waves and it'll bob up and down, and you can use that to make electricity in creative ways. And those waves aren't diminished in any way. The waves will keep going up and down. For instance, it's really popular to put solar panels on top of your house nowadays. That's a great way to generate some extra electricity and save yourself some money, but also it's really good for the planet. And you can see how the panels are producing kilowatts, which we will talk about in the video, which you're going to watch. Wind is another popular renewable source, and there's different kinds of wind turbines that spin and create electricity as they turn a coil inside a magnet. We're not going to talk about that as much since we can't make windmills ourselves, which is what we were going to do had we not had school move to online. Lastly, we have kinetic and potential energy. So any energy that is stored and then could be released at a later time is potential energy. You might think of potential gravitational energy. If I lift up this book and then I keep it here, it has a lot of potential energy to move if I were to let go. If I let go, it's all transferred to kinetic energy as it moves. Kinetic energy is the energy of motion. So you can think of like a water wheel being turned. It's being physically moved. Kinetic energy is being applied. So something interesting to think about is if you have an electric fan, how does the electricity get there? What kind of stages does it go through? Well, it actually goes through quite a few of the stages we talked about. You might start as coal, chemical energy. Its potential, it's stored in this hard rock-like form, completely inert until we apply some initial energy to it to get it to heat up. And then all that stored potential energy is released as thermal energy. It's heat. Now that heat is used to actually take a bunch of water and create steam. That steam rises up and turns a large turbine, which turns a big coil of wire inside of a magnetic field, thereby exciting electrons and causing them to move. So you have your mechanical energy of steam going into mechanical energy of the actual turbine turning. And that creates your electricity. Now the electricity travels from station to station, all the way to your house, and finally is transformed back into mechanical energy as the fan turns and cools you off. There you go. Something interesting to think about. So now coming back to how your light turns on when you turn on the switch. Were you guys able to figure it out? Well, if you haven't, or maybe you're not sure, the actual answer is all the electrons inside the wire start moving at once. So even though each individual electron might not move really fast, because they're all going together, they're kind of, think of it like a really unruly grocery store line. If someone behind you pushes you, you're going to get moved forward whether you like it or not. All the electrons move at the same time. So that's why when you turn on the light actually turns on right away, even though the electrons from by the switch won't reach it until a little bit later. So something cool to think about. Once again, please don't forget to do your assignment, which is posted on your modules. It's due Sunday, and stay safe out there. Email me if you have any questions. Have a great rest of your day.